3 or 4 layers or 5 layers from the paint found at the crime scene and the paint on the suspect's car in the right order, then you pretty much know that's exactly the source of the paint found at the crime scene. Let's say a person was hit by a car and paint was left on his clothing. Well, and we found a chip of paint on his clothing that had layers of red, white, blue, and green. And we suspect we have a suspect's car, and we go to the suspect's car, and lo and behold, that's the same thing: red, white, blue, and green. It's pretty clear that the suspect's car is what left this paint at the crime scene in the accident when it hit the victim. Be aware that layering also can exonerate. For example, on the crime scene was red, white, blue, and green, whereas we went to the suspect, we found he had red, let's say red and green, just red and green. So there's no, I mean, if you would have found red and white, I mean, you could say, well, maybe only the first 2 layers were found were scraped off onto the victim. But if you find red and green on the victim, and the suspect has red, white, blue, and green, I mean, there's no way he could have gotten the red and green without getting the white and the blue. So we know that this suspect is innocent. Their layering is what exonerates them. So layering is very important. How many layers do you have to do to match? One of them is pretty much not enough. I mean, a lot of people might have a blue car. What we want is like at least 2 layers. Are 2 layers enough? I mean, yeah, a lot of people have blue cars, but who paints it red over that? Not that many people have both blue cars and paint red over that. So is blue is 2 enough? Well, when you get to 3, now that's very improbable that it's random and they're not connected. So how many layers? Again, you have to use, often you can use common sense. It's like 10 layers, obviously, it's the same. But if it's 1 layer, that's really not enough. So again, we have professionals who are supposed to be able to relate them, and they can provide more information. But certainly use your common sense. If a professional tells you 1 layer is enough, they've got to have a good reason, because lots of people can have the same color paint on their car. Anyway, the paint evidence, it's not, most of the time, apparently, the forensic paint evidence does not have layering is just not enough. When I say that, I mean that they don't recover enough layers to use layering as a way to prove the suspect's connection to the crime scene. They just don't have enough layers. They might only have 1 layer at the crime scene, so they can't really connect it to any suspect with any evidence. So sometimes what they have to do is find some other way to connect it, and this is done by like trace analysis. And we'll talk a little bit about that here. One way, if you just have, let's say, 1 coat, 1 paint chip with only 1 coat or 1 layer of paint, or just 1 color, what you do, and you want to connect it to the crime scene, you heat it up until it forms a gas, and when this gas is put through a gas chromatography column. Gas chromatography, as mentioned before, is when as different gases, you put them through a certain column, each gas will stick to the column in a different way, and therefore they will get through the column at different times. So this is gas chromatogram over here. Here's like one part of the paint, let's say, came over here. There's not much of it. Then some came over here at what is this, 2.5 minutes, let's say, came out. And these are different components of the paint. When they turned it into gas and put it through the gas chromatography column. This one was really slow; only came out after 15 minutes. But the point is that all these show the major components of the paint, and different paints. They're all made in different places, different ways. They might both be blue paint, but every factory can make their blue paint in a slightly different way, using different components to get to the blue that they're interested in. So even if the color might be the same, the different components used to make the paint is likely to be different, unless it was the same batch, or unless it was the same paint. It has the same source. So if you take two like a visual identical paint colors, let's say they're both green, and you put them through the chromatogram, you put the crime scene one through the chromatogram, and you put the suspect's the suspect's paint chip, collected paint chip, through the gas chromatogram, and it comes up with the same pattern, then there must be a connection between the two. It's not perfect, not a definite connection, because it's possible that they both had their the real criminal and the suspect, they had their cars painted one after the other the same place. It's possible. I mean, so it's not a perfect proof, but it definitely shows some kind of connection between the paint found at the crime scene and the paint of the suspect, if they have the same gas chromatogram after pyrolysis. So this system is called pyrolysis. Pyro meaning like burning or heating up. And when you heat up the paint, it'll turn to gas, and the different components can be found with this chromatogram, and we compare the different chromatograms. If they're the same, they have the same source. Or that's the conclusion. There's another way. If we just take this paint and instead of pyrolysis, we put it through IR spectroscopy. Now, as mentioned before, IR spectroscopy identifies the compounds that are found. And one compound will have one IR spectrum. So we can put the thing through IR spectroscopy and find if it's the same compounds that went into the paint, just like the pyrolysis. So here we use IR spectroscopy. We send infrared IR, it's infrared light into it. We see where it absorbs and where it doesn't, and we can tell, and by that pattern, exactly what it is. And we can tell if two paint samples have the exact same one, it's very likely they had the same paint. It has the same source. But again, maybe they both got it painted in the same place. But generally speaking, we don't really assume that. Again, it's highly improbable. But again, it's possible, which is, again, that's the area where the lawyers might be able to argue with. But if it's the same, if it's composed of the same thing, then it's likely that, the suspect's car left the paint there. That's why it's the same thing, because the same paint job. Except this paint job was scraped off onto the criminal, onto the victim at the crime scene, and this was left behind in his car. But it's the same paint. Also, we can look for trace elements in paint. Sometimes you might find some trace elements in the paint, because again, everything is impure in some way. So if we realize that they both have the same trace elements there, like somebody might find lead in there. What's lead doing there? We've all heard of lead paint, but people don't use lead paint anymore. If they have some iron in the paint, now why is there iron in the paint? It doesn't belong there. If it's there in both cases, well, again, that shows a connection. So sometimes you find these trace elements in there, and you can use it to connect them. Now, paint evidence, as we showed how we connect the suspect to crime scene paint evidence. Well, if we connect it, how useful is it? It's actually very useful. That's what we mentioned, using IR spectroscopy to say that the paint is composed of the same components. Now, the problem is, it was mentioned that maybe the two cars got the same paint job. How likely is it two cars got the same paint job in the same place? They